So we lost it because the time stipulated time crossed, so crossed 27. Screen is visible, right? Please respond. Screen is visible. Yes, ma'am. Okay. 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 Let others come. Just wait. Let's wait for 2-3 minutes. 33. I'm not locking the meeting. Let others come. Okay. So basically, that is we have discussed what is structure, right? Then based on different structure, it will carry different loads. Then every material has its elastic limit. After that, it will get fractured. Okay. So all materials and structure deflect to greatly vary extent when they are loaded. And the science of elasticity is about the interaction between forces and deflections. The material is stretched near its upper surface and compressed or contracted near its lower surface by the weight of the monkey. So this is our residential building. What we It will have its live load, it will have its dead load, right? All the loads are transferred to the slabs, and those loads are transferred from the slabs to the columns, and that loads will transfer to the earth. Okay. So we discussed deformation and strain. This is three important points. The basic difference: strain is force, and deflection is change in shape. It is measurable quantity, and deformation is non-measurable quantity. The strain on an object strictly depends on the external load, but for the deformation, it depends on external load as well as material. Okay. So we were discussing what? We were discussing this your equations, right? Let me close the participant list. Okay. So, determinate and indeterminate. A structure can be called as determinate. My screen is visible, right? And cursor is also moving. Please let me know once. Screen is moving and cursor is also moving perfectly. Please respond quickly. Yes, ma'am. Thank you.
Yes, ma'am.
Ma'am, screen is visible, but cursor is not visible, ma'am.
Cursor is not visible. Now I have drawn a line, red color line,
Yes, ma'am, now it's visible.
visible, right? Thank you. Okay. So we have been discussing that I was telling you that we have a structure which is it is termed as determinate and indeterminate. Okay. So when the structure is called as determinate and indeterminate, so the structure when follows this static equations of equilibrium. What are the static equations of equilibrium? It is summation of fx. Those who are not able to see my screen due to network, please open the uh, file. Okay. So summation of fx, fy equals to 0, and summation of m equals to at that point equal to 0. If these three equations are if these three equations are applicable, or it is suitable to find out the reactions on that structure, or it is able to solve the calculations like reactions on that structure, then your structure is determinate. But less equations are available than the number of unknown forces than constrained in the body. Suppose these equations are not sufficient to find the reactions on that structure, then we'll need extra equations. Then your structure becomes indeterminate. Okay. So hope this part is clear. Next, see what is the free body diagram. What does this mean by free body diagram? So it is a simplified picture of the structure isolated from its supports, on which are shown all the external forces that act on the structure. Suppose assume this is a beam is given to you. This is one load. This is one support which is roller support, and this is one hinge support. Okay. and this beam is loaded with one load. So this will be your free body diagram. The roller support is represented by one reaction, hinge support is represented by two reaction, and load is simplified. So this is your free body diagram. Okay. Next, equation of equilibrium, as we discussed, external horizontal forces will be balanced. That means this line says summation of fx is equals to 0. External vertical forces balance. This means summation of Fy equals to 0. Summation of force or reaction in y direction will be 0. External movements balance about any point. This means summation of movement at that point will be equals to 0. So these three are the equations of equilibrium for in 2D. Okay. So the above requirements may be stated mathematically as this: summation of fx equals to 0, summation of fy equals to 0, and summation of mz equals to 0. Now, screen is visible and cursor is moving, right? Please let me know by time to time, otherwise I won't be able to continue. Cursor is moving. I've drawn a red line. Please respond. Yes, ma'am. Okay, thank you. So, see, so this is the sign convention. If I'm taking this one as positive, suppose these are the horizontal forces. These are the horizontal forces, right? So if I'm taking this one as positive, I have to take this one as negative. Suppose this is your beam. A force is acting on. Suppose your beam. A vertical force is applied, and one horizontal force is applied in this direction and this direction, and one vertical force in this direction. Suppose I'm taking this one as positive, I have to take this one as negative. If I'm taking this one as this vertical in this direction, vertical direction is positive, I have to take whatever the force in this direction as negative. Okay. And in the further movement, if I'm taking and if I'm taking anti-clockwise as positive, I have to take clockwise as negative, or at like that. If I'm taking anti-clockwise positive, then I have to take clockwise negative, vice versa. Okay. So these are the types of supports and restraints. What are the types you will get later on? That it will have roller support, it will have hinge support, and it will have fixed support. And based on these forces, you have your reactions. Now you will understand why for roller support, why I have drawn only one vertical line in earlier slides. Right? See, for the roller, I have drawn only one vertical line, and for hinge support, I have drawn two lines. So this is fixed, that your roller support will only resist the forces in y direction, that is vertical direction. It will have reaction 1. And your hinge, or you can say pin support, will have, it will resist the direction of vertical as well as horizontal. So it will have reaction of 2. Again, for the fixed support, it will have three direction resistance in three direction: one horizontal, one vertical, and one movement. It will resist your movement also. So these are the basic three supports: roller, hinge, and fixed, and it will have reaction like this. These are the practical examples of different supports. A column is assumed to be pin connected at base. Suppose this one is your column. Suppose this one is your column. It is supported at pin support, and it is connected to a beam which is fixed connection. Okay. At the base it is pinned, but this column is connected to a beam as fixed. Okay. Now two girders and floor beam are assumed to pin connected to this column. This is one girder, this is the second girder, and this is your floor beam. All three are connected to this column as pin support. This girder is connected to this column as pin support. Again, this girder is connected to this column as pin support, and this is a floor beam connected to column as a pin support. These are the examples of support in our day-to-day life. These are structure of a bridge. Okay, this and this point is a hinge support. Suppose this is a slab beam. Okay, this is a slab beam of a bridge. So this is at hinge supported to this abutment, Here, this is a hinge supportment to this abutment, and here a roller support is provided to you to resist the vertical motion. Here, it will resist the vertical as well horizontal position. Here also it will resist the vertical and horizontal position, but here it will resist only vertical because there is no chances of horizontal because it is fixed at this. Okay, that's how you draw or you can take. These are the typical of rocker support used for a bridge girder. When you see a bridge, you will get these supported in your everyday day-to-day life. This is a pin. This is the support. This is the support given to this girder and this girder. This is one girder. This is one girder, and it is joined by a pin support. Okay. Again, this is a pin support. You'll get pin support, roller support. This is a roller support, fixed support, like this. Okay. So, as I discussed earlier, we have discussed in earlier slides, a structure for which all unknown reactions can be determined using the equations of equilibrium is referred to as a determinate structure. So, whatever be the unknown reactions can be determined using equations of equilibrium is referred to as a determinate structure. Next, this is the structure is given to you. Okay, this is the structure given to you. This is the roller support, this is the hinge support. So what are the reaction it will have? It will have this vertical reaction at this point, right? At this point, so let's draw free body diagram of the structure. So if we draw free body diagram, there will be one reaction in this direction, a load. Just assume that this load is vertical load. Just assume. Okay, vertical load. You have been given horizontal load, and you have, right, this will be free body diagram or not. So determinate structure is that when your equations of equilibrium is sufficient to determine the reaction, and your indeterminate structure which causes more unknown reaction than equations of equilibrium. This is an indeterminate structure. And your unstable structure will be the structure in which there are insufficient number of reactions to prevent motion from taking place. Okay, it will have insufficient number. The reactions are not sufficient to prevent the motion of the structure. Earlier, it may be more reactions or less reactions, but here the reactions are insufficient to change its motion. Idealized structure. A structure is made of is a structure is made in a line form and the supports are replaced with reaction. So basically, free body diagram of the structure is termed as idealized structure. See, it is given here a column and beam is attached, right? So the structures are represented by here a line diagram, and these structures are represented by line diagram. So this is the actual structure, this is the idealized structure. Same, this is the structure, column, girder, joist. So these supports are represented by here line diagram. So this is the structure, this is the idealized framing plan. Same for the fixed connection beam, the all the joints are represented by line diagram. See, this is a fixed connection overhanging. All the supports are represented by a line diagram. So this is the idealized structure. Now let's discuss what we are discussing: statically determinate structure and statically indeterminate structures. In this section, in this module, we'll discuss statically determinate structures. In the later module, we'll analyze these statically indeterminate structures. But you should know what is the basic difference between these two structures. So for this is statically indeterminate. See, if you want to draw a free body diagram of this beam, suppose roller support will have one reaction. Hinge support will have your two reaction. One is vertical direction, one in horizontal direction. Right? What are the number of unknown reactions? 1, 2, and 3. Right? You have unknown reactions 3, and you have equation of equilibrium also 3. So this is one way to know your structure is determinate or not. Okay, so this is your determinate structure. Now let's come to statically indeterminate structures. For the hinge support, if you want to draw a free body diagram of this, we'll have vertical force and one horizontal force. Again in this direction we will have vertical force and horizontal force. So how many number of reactions there are? One, two, three, four. Four unknown reactions, but we only have three equations of equilibrium. So this will be indeterminate structures. Okay. What you have to do, you have to draw the free body diagram. You have to see the reactions and compare with equations of equilibrium. Now come to this part. As we have discussed, your fixed beam is generally used to have three reactions. One, two, and three. Right. So this is one vertical, horizontal, and motion. Vertical, horizontal, and motion. So what will be the number of reactions? It will 3 plus 3 will have 6 reactions, right? 6 unknown reactions, but we only have equation of equilibrium 3. So this one will also be your indeterminate, statically indeterminate structures. This is statically determinate structures. So under the statically determinate structure, let's discuss the topic or structure truss. Okay, the truss is a structure composed of slender members. Slender members means two force members where two forces are acting. So this joined together at their end points to support stationary or moving loads. You will see those trusses mainly in bridges. You have seen the truss bridge over the Brahmaputra, which is called as Saraighar, I guess. So this is the members joined at the end points. This is the one end point. This is one end point. Those members either in tension or in compression. Okay. Each member of a truss is usually of uniform cross section along its length. See, if you see the truss along the member, all are in uniform cross section. There is no different cross section at this point and this point. So during the calculation or analysis of these trusses, few assumptions are made. That number one is the loads and reactions act only at joints. So whatever we apply the load and the reaction generated on truss is only at joints. See this, I am applying a load at only joints. Okay, so loads and reactions act only at those joints for the truss member. When we apply load on the middle part, it will become a frame. Okay, at truss we only apply loads and reactions at joint, but if we apply a load at suppose this point, so this truss will become your frame. And this I don't know, I have to see that frame in your I think frame is in your another subject, analysis of structures. It is taken by Junaid sir. Okay. So there's a difference between truss and frame. So in truss, loads and reactions only act at the joints. Next we have that weight of the individual members can be neglected. We generally neglect the weight of the members, and those members are either in tension or in compression. Those members are in tension and compression. So we find out the compression tensor based on the sign convention we have studied earlier. Some we have used to take tension as positive, compression as negative. Sorry. So your joints are usually formed by bolting and or welding the members to a common plate. So whenever you see the truss member or truss section on this, those members are jointed by either bolting or welding. Bolting means you used to provide some screws on or screws to join the members. This one is the one member. This one is the one member. Both are joined to a plate, which is known as gusset plate, and these are the bolting. Okay, these are the bolt. You study the design of this bolt gusset plates in next semester. But the joints, you should know that these joints are usually joined either by bolting or welding to a member which is common plate. See, this is one member, this is one member, it is joined by a common plate. So joining in these structures, how we join the structures in RCC? Column and beam. We provide reinforcement, right? We join a column and beam by reinforcement. But in steel structures, truss is also steel structures. We join those members to a common plate either by bolting and welding. So in analysis of trusses, truss analysis, we have two parts: external equilibrium and internal equilibrium. Always remember a structure can be externally equilibrium but not be internally equilibrium. So we have to make those trusses externally stable as well as internally also stable. Okay, the truss may have your truss may be externally stable but not be internally stable. So you have to check both the parts, external and internal. How you will do the external? How you will check the external stability? To find the reaction forces. Externally, you have to find the reaction forces of acting on those on that truss, and internally there are two parts. In internally, you have to find the force in each member. Externally, you have to find the reaction forces acting on the truss member, and internally, you have to find the forces in each member. What are the so op- okay? Screen is not clear. Is it with Mayak or others also? Screen is not visible. Please respond. Analysis of structure, truss analysis. I have opened the part of truss analysis, external equilibrium and internal equilibrium. Please respond. Is this issues with Mayak or go back and try again?
So it's visible now. Now it's visible.
It's visible. Okay. So basically, please open the. Okay, no. You won't be able to open the PPT at the same time. Okay. So analysis of truss. Now it is visible. Okay. So analysis of truss will take your you can analyze the structure by two you have to check the stability of the truss by two way, externally and internally. In externally you have to find the reaction forces on the structures, and in internally you have to find the forces in each member by the method. There are two methods available, and we can analyze this. We can find the forces in each member by two methods. One is method of joints, another is method of sections. Okay, so let's start with external equilibrium or external to find the reaction forces. To find the reaction forces, you have to follow these are the basic steps. What you have to do, you have to draw the free body diagram of the entire truss system. Whatever the truss is given to you, you have to find the free body diagram of that truss. Okay. Then determine the reactions using the equations f of x equal to 0, f of y equal to 0, and f of m equal to 0. Suppose this is the truss given to you. Okay, it has joint A, B, and C. Okay, this is the roller support, this is the pin support. So you have to find you have to draw a reaction. Then it is has been applied an external load of 500 newton. So free body diagram of this truss is this one. What is the difference between these two diagrams? Here we have shown the reactions also. So at C point it will only have Cy, and at A point it will have Ax and Ay. And this is the 500 external load. Next come to method of joints. Okay. So basically what we do in the method of joints, we find the forces in any member. Suppose this is your, just wait a second. Suppose this is your truss. You have to find the force in the member AB. So you have to choose joint B and A, and you have to calculate the reactions and find the forces in is this member. For AB member, you need to find the forces in A and B joint. You have to choose these two joints. So to find the forces in any members, choose a joint to which that member is connected, as I discussed, and follow the below steps. Draw the free body always with the first procedure used to whatever truss is given to you. You first draw the free body diagram of the truss. That this will be the first step in all the cases. Okay, this will be your first step in all the cases. Then you have to determine the reactions. What are the reactions on those on that truss by using these equations. Then choose the joint and draw free body diagram of a joint with at least one known forces and at most two unknown forces. Suppose this is the truss. Okay, it has joints A, B, and C. Truss is supported by a pin joint and a roller support. An external load is applied to that beam. An external load is applied to that beam, which is P. So when you draw, this is your free body diagram. This P value will be given to you. Okay. Based on that value, you can find Cy, Ay, Ax. That was your second step. You have to determine the reaction. Taking summation of all the forces in x direction equals to 0, all the forces in y direction equals to y, 0, and movement also 0. So basically in truss you will get only these two types. Okay. Movement comes in frame. So once you find out the reactions, suppose you have to find the forces in the member AD. So there are two joints, A and D. So they have drawn the free body diagram of A and D. Okay, based on the distance and not. So suppose at A point one reaction is P by 2, and at D point this P is divided to this and this member as 0.687 P and 0.66. Forget about this part. Just see the you'll understand when once we start with numerical, and we'll start the numerical in the next class. Just see the forces. Just see the steps. These two steps are here, I guess. Then you have choose the joint and draw free body diagram of that joint. We have drawn the free body of that joint where at least one force known force. So you have this force as known, and you have to find these two forces. At this point, at least one force, means at least all the forces on that member, you should know at least one force, and at most two unknown forces, not more than that. Then equation of equilibrium will be justified. Then using the equations like this, you have to find the internal forces again. Then you have to choose the next joint. Okay. Then we'll do numericals on method of join and method of sections as well. So let's see the what is method of section also. Okay. So your method of section, what we do to find the forces in any member, choose a section to which that member is appeared as an internal force and follow the steps. So what you have to do, suppose you have been asked to find the force on this member ED. So ED is connected. You you can take you can take this section A. They have taken a A section. Okay. So first, always you have been given a truss. You have to draw a free body diagram. This is the free body diagram of the structures. Pin joint, two reactions is given. Roller support, one reaction is given. Load is given to you. These are the structures. Now what they have done, you need to find the suppose member in this direction, in this, suppose any member. So take a section where this that member, suppose you have been asked to find the forces in this member EC. So take a section and on which this member is coming under. Okay, suppose I have taken a section as like this. I've drawn the free body diagram of that section. So this is your first step. Draw a free body of the entire truss. Find out the reactions. That this means, see, if I take all the vertical force equals to 0, so I will get from this equation, if I'm taking Ay is positive, right? Ay is positive. I need to take this one as negative. So minus 1200 equals to 0 or not. For the summation of Fy equals to 0, I can write, for this condition, I can write Ay minus 1200 equals to 0 or not. From here, I'll get Ay equals to 1200. Is it or not? Clear? Oh no, I have one more forces. Ay plus dy minus 1200 equals to 0. So I will have ay plus dy equals to 1200. This will I get one equation. Next, I'll have all the summation of all the forces in horizontal direction equals to 0. So I have a force in ax, right? Suppose I'm taking this direction as positive, ax as positive. So again I have one force which is in opposite direction 400. So I got 400. In the same way, using these equation, I have to find ay, dy also. So that is step number 2. Next, the step came, you have to choose the section and draw free body diagram of that section. I have chosen this section and I have drawn the free body diagram of that section. Shows how the forces replaces the section members. The section member are replaced by these forces. And again with the same equation you have to find the forces, these forces FGE, FGH and FBC. Okay, so this is the basic process. Now comes the important part. There is a called zero force member. Okay, what is zero force member? Analysis of truss system is simplified if one can identify those members that support no load. Okay, there are sections in the member, in the truss member, which supports, which carries, that supports no load. That doesn't take any load. That doesn't get any member. If two members form a truss joint, then and there is no external load or support reactions at that joint, then those members are zero force members. Suppose in this section, take a joint D and A. This is the joint D. Okay, two members form a truss joint. This member ED and CD. It is making a joint D, right? See, two members form a truss joint. These two members ED and CD, they are making a joint D, right? And there at joint D, no load is applied to this point. No load is applied, no support is given to this joint. So this member is your zero force member. So force in DE and force in DC will be your zero. This was I was talking. Since this is the same, if two members form a joint, these two members ED and CD forming a point joint D, and this joint does not carry any external load as well, it doesn't support any reaction. So this will be your zero force member. That means force from D to E and force from D to C will be your zero. Okay. In the same way, see this member FA, or you can say AB. This is one member. It is making a joint A. At this joint, no support is given to this joint. Again, no load is applied to this joint. Right. So, so this will be your zero force member, and force in AF and AB will be zero. This one. This is the free body diagram they have drawn. So force in FAE and FAB will be 0, and FDE and FDC will be 0. Is that clear? Is that clear? Please respond. So again, there is one example we have. If three members form a truss joint and there is no external load or support reaction at that joint, and two of those members are collinear and the third member is a zero force member. So zero force member is also called, in this figure, AC and AD are zero force members. See, this is the figure AC and AD. That means joint D and E. They are talking about the joint D and E. So force in FCA and FDA. See, this is the two joint again where no load and force are acting. Okay. So this is also a zero force member. We'll solve the numerical in the next classes. Okay. Till then, you study about from the slides also, and you'll get in YouTube also. If you find any difficulty, let me know. I'll explain again once more. What is the determinate and indeterminate structures, idealized structures, then what is the zero force member, okay, how to find these reactions. Just give it a little brief so that it will be clear in the next class. Okay, we'll do the numerical in the next class from the by method of join. I've shared the PPT. You can go through your PPT if you understand. If you don't understand, no issue. I'll also I'll also discuss this in the class. So thank you. Don't leave the class. Give your attendance in the chat box. Don't leave the class, okay? Until I say write your roll numbers in the chat box.
Hello.
Yes, yes, Mr.
You should know for lecture 4, 5, and 6.
Your voice is not audible. Can you write in the chat box? Your voice is not audible to me.
Yes.
Those who have any issues, please write in the chat box. Any issue regarding the class, or you can go through the recordings of section A also. Ma'am, can you share the notes for lecture? Yes, 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 surely, surely. Today, after uploading the notes, I'll share the 4, 5, 6 lectures also. Thank you for reminding me. I'll share. Anything else? Please go through. Please go through your earlier these points I have discussed today. Okay. Please go through. You will get plenty of this notes over the Google. And if you want me, let me know. Okay. Motiu Rahman. Why are you writing now? Let me tell you. Everyone wrote their roll number? Please let me know because I'll end my Atul Tata he cannot. Yes, yes, I was seeing him. He was joining the meeting and he was trying to join the meeting. Okay. Okay, everyone wrote their roll number, I guess. Vika, don't write two, three times. It makes me confused. Okay, thank you. गुनेश्वर क्यों बार बार लिख रहे हो गुनेश्वर हो गया एक बार हो गया आई एम एंडिंग द मीटिंग